Go for it.
Yes, thank you. So can anyone see my screen now?
Yes, perfectly.
Okay, so excited. This is my first time to join the KubeCon as a speaker. So it's my great honor to be here. Thank you for having me. Before we get started with this talk, let me introduce myself. So my name is Feynman Zhou, and I come from China. I'm a CNCF ambassador, KubeSphere community manager, and D-Zone core member. In this talk, I will briefly introduce an open source container platform, KubeSphere, and its open source ecosystem. So I hope this talk can bring you guys to a cloud-native journey and unleash the multi-cloud potential with KubeSphere. All right, let's see what we will talk on this session. So at first, I will walk you through the pain points and the challenges of implementing Kubernetes in production. And then I will introduce an open source container solution, KubeSphere, and its open source ecosystem. And next, I will give you an interview demo to show how to deploy and distribute a web application to the multi-cloud and multi-cluster environments. And the last, I will briefly introduce the KubeSphere community. I hope you guys can enjoy this talk. Okay, at first, let's take a look at some statistics. Has anyone noticed the report from CNCF Survey 2020? As you can see from these two bar charts, you can easily find some notable trends. Most of enterprises have more than 2 Kubernetes clusters in production. It demonstrates that one Kubernetes cluster doesn't address all your needs. Let's move into the second graph. All right, you can find that multi-cloud strategy has emerged with 26%. Oh, this has never happened before. It means that multi-cloud has been a new option for enterprises to run Kubernetes in production. So let's take a look at the first and the second indicator. You can easily find that most of enterprises still choose to run Kubernetes on the private cloud and on-premise. Well, I think you're going to have a couple of questions. Do you know why enterprises choose to set up multiple Kubernetes clusters? Definitely, the cost of maintaining a single Kubernetes cluster is not cheap, but most of CFOs are willing to afford the Kubernetes cluster expense. Because enterprises have no choice, there are enough reasons and requirements that enterprises have to implement multi-cluster and multi-cloud strategy in production. So you can see from this slide, typically we have seen 4 common scenarios from our investigation. In the first case, if you want to separate applications and environments in different clusters, so you have to set, for example, development, testing, and production in different Kubernetes clusters. So you may need to take the strategy for cluster per application. For instance, you may need to create a cluster with GPU nodes only for the machine learning and AI application. So you have to set different clusters for the single use. Okay, let's move into the second case. So there's no doubt that some enterprises may have multiple cloud providers. They want to leverage the best tools or services from the different cloud providers. The vendor lock-in and high availability are also reasonable for them to adopt many Kubernetes clusters in different cloud providers. So in this case, you have no choice, and you have to follow the pace to adopt multi-cluster strategy. In the third case, we can find that due to the company structure, different department or team owns different Kubernetes clusters. Business isolation, multi-tenancy, and security might also be a key reason for them to adopt multi-cluster strategy. And the last, especially we can see this scenario in banking, insurance, finance, and the live industry. The geographical redundant that we need to choose multi-cluster model. If you want to provide services close to customers and you want to build multi-dimension high availability by using multiple regions, available zones, clusters, or cloud providers, so you have to build multiple Kubernetes clusters across different regions or available zones. So in addition to these parts, you may want to get failover, fault recovery, and load balancing on multi-cluster. All of this makes you to adopt the multiple Kubernetes cluster in production. So let's move into the next slide, and you will find the CNCF survey. The most obvious thing is that complexity occupies the biggest challenge when people adopting Kubernetes in production. The complexity always causes the high learning curve when people use Kubernetes and its open source ecosystem in production. On the other hand, Kubernetes cluster bootstrapping has never been an easy thing. If you want to set up a highly available cluster in production, you may take 1 or 2 days to explore and find the best way to set up it. In addition to this, application lifecycle management, multi-cluster and multi-cloud management, security and multi-tenancy has been the pain points for people to adopting Kubernetes in production. Kubernetes is fascinating and well architected with a bunch of benefits, auto-scaling, self-healing, and rich ecosystem. But when people really want to adopt Kubernetes in production, you may complain to us, Kubernetes is not as perfect as you imagine. Since Kubernetes has never been a single tool, it has a rich ecosystem that every developer or SRE need to consider. Fortunately, thanks to the CNCF and the cloud-native ecosystem, we have a lot of open source solutions and projects which help us to solve the pain points and challenges as we talked about. For example, we can leverage Elasticsearch and Kibana to build a logging system. Or we can use Grafana and Prometheus to create a monitoring system. And we can use Istio and Jaeger to build a service mesh platform and tracing. As well as the Jenkins and GitLab, we can create a CI/CD platform based on them. As for Kubernetes itself, we have Kubernetes dashboard, which help us to view and to select the resource consumption and utilization in the cluster. Well, this things looks fascinating, but it will also introduce some new pain points. Look at this face. I think you may remember the famous Chinese Kung Fu superstar, Jackie Chan. So all of these things will bring you into a mess. You're gonna have a few questions. Does the developer really need to be a cloud native or Kubernetes expert? Do they really need to master a bunch of these tools? I'm gonna have a question for you. Why not let developers focus on their own business and application development? Okay, at this point, we know that the complexity of the open source cloud-native toolkits seems to be a big deal for developers who want to adopt Kubernetes in production. So KubeSphere might be one of the solutions to help you to solve the pain points and the challenges as we talked before. All right, what is KubeSphere and what pain points does KubeSphere solve? KubeSphere is positioned as a container platform, and KubeSphere is a distributed operating system managing cloud-native applications with Kubernetes as its kernel. So you can imagine Linux kernel and Ubuntu desktop. So you can regard KubeSphere as a desktop with Kubernetes as its kernel. And KubeSphere provides a plug-and-play open architecture for third-party applications, seamless integration to boost its ecosystem. By the way, KubeSphere is totally open source and free to download. So you can get the source code from GitHub, and you can get the documentation and more information from KubeSphere website. All right, let's take a look at the general architecture of KubeSphere. It brings you a portfolio for deploying and managing cloud-native applications, which contains the service mesh based on Istio, the CI/CD platform based on Jenkins, the application management backed by OpenPatrix and Helm, and the observability platform includes tracing, monitoring, alerting, and notification, and the security platform. All of these components are pluggable, so you can enable and install them as you need. Oh, last but not least, you can install KubeSphere on any infrastructure. Well, let's take a look at the ecosystem tools of KubeSphere. As you can see from this graph, KubeSphere integrates a wide breadth of tools ranging from cloud-native applications to the underlying container runtimes. These open source projects serve as the backend components of KubeSphere, which interact with the KubeSphere console through standard APIs, providing the built-in web UI and consistent user experience in a unified console, which helps you to reduce the complexity. Well, when it comes to the comparison with Kubernetes, we would say KubeSphere stands on the shoulder of a giant. Let's take a look at the comparison to Kubernetes and KubeSphere. KubeSphere features some capabilities that are not available in upstream Kubernetes. For instance, service mesh, CI/CD platform, application management, and observability. So KubeSphere alleviates the pain points of adopting Kubernetes in production, especially for the installation, storage, and network provision and the usability. At this point, we can draw the conclusion is that KubeSphere is positioned as a central control plane for managing multi-cloud and multi-cluster. It is designed for hybrid cloud, so users can easily distribute and deploy a cloud-native application across different Kubernetes clusters. Okay, so let's jump into a demo in 5 minutes. In this demo, I will deploy and distribute a web application across multiple hosted Kubernetes services. We will have Amazon EKS, Azure AKS, Google GKE. So let's take a look at the demo. Here, this is the KubeSphere console, and we have 3 clusters imported into here. The first one is Amazon EKS. We name it as Gondor. The second cluster is Azure Kubernetes Service. We name it Share. And the third cluster, Google GKE. We name it Rohan. So after we imported these 3 Kubernetes clusters, we can drill into the workspace. Okay, the workspace is a multi-tenancy model of KubeSphere. Here we can create a project which is equal to the Kubernetes namespace. And here we can create an application. We name it as app testing. Click Next, and here we can create a stateless service for this sample application. Here we can configure the different replicas for different cloud providers and different Kubernetes service. We can enter the Docker image. This we use a sample web application, save it, and next, pay attention to here, we can set the environment variables. Here we can use the environment variables and display it on the web application. Here we can use the class name. For example, Rohan and Gondo and share as this value. So you will find the class name on the web application as the final. Same as above. Transfer the class name in this, fill out this form and click add. Here we fill out and create this application. And now we can find the workloads and its deployments have been running in different clusters. And we have different replicas distributed on the Kubernetes services. Here we create a root, which is Kubernetes ingress, help you to expose the Kubernetes service outside the cluster with domain. And here we can configure the domain name with the cluster name. So at first, we can use Rohan for the first cluster. We can configure the container port at here, and we can save it. Same as before, we can use share for the second cluster. Save it. This is the same with the previous step. We can use Gondo as a class name and domain. Okay, all of these have been completed. Then we can click next and create it. And now we can access the web application on our browser. Okay, you can find the first application is running on the first cluster, Rohan. The second service is running on the second cluster. The third one, parameter variable is also showcased on the landing page. Okay, let's back into our slides. I hope you guys can understand this multi-cluster demo. At this point, I would demonstrate and introduce the globalization and ecosystem of KubeSphere community. So far, we have 10,000 downloads and totally 200 contributors in our community, and 5,400 GitHub star. As for the internationalization, KubeSphere has support English, simplified and traditional Chinese, Spanish, and Turkish in KubeSphere console. So far, we have 3 hosted services powered by 3 different cloud providers. You know, AWS with AWS Quickstar to provide Amazon EKS integrated with KubeSphere, and KubeSphere on Azure Marketplace integrated with Azure Kubernetes Service. And the third one is ChinCloud App Center, which is powered by our company, ChinCloud. Okay, let me briefly introduce the KubeSphere community. You can see the list, how many contributors who joined our community and our community partners. More contributors and partners are welcome. Okay, thanks for your watching. So at here, we listed some frequently asked questions, and you can ask me anything. So people may ask me about what are the popular open source multi-cluster solutions. I would say Kubernetes Federation, also known as KubeFed, and the Commander is open source and maintained by Huawei, and the Rancher, which is the most popular multi-cluster management tool. Let's take a look at the second question. What is the underlying implementation of KubeSphere multi-cluster? KubeSphere multi-cluster is also built on Kubernetes Federation. So if you have any more questions, you can ask me on Twitter, on Slack, on YouTube channel. So, but I think I have completed my presentation.
Sorry, very, very good. Fantastic. Actually, we do have time for one question, Feynman, if that's okay. Someone whose name on YouTube is the Panda Guitar asked, does KubeSphere expose an API?
Yeah, it has the standard API for our tools to invoke.
Very
you can find the API documentation on our website.
Okay, it's on the website, the documentation. Perfect. Maybe Feynman, when you finish, you can leave the link where people can find that documentation in the YouTube chat so that people can access that. But I think we can all agree, Feynman, you did a wonderful job in your first KubeCon talk. It was very informative. We got lots of great insights. We have lots of good active conversations going on in the chat in our YouTube channel. So I think with that, and also just a reminder, if you have questions as well, you can ask Feynman, you can ask Patrick, you can ask all of our speakers questions in our Slack. All right, we put the link to our Slack in the chat a couple of times, but please keep these conversations going. That's what this is all about, all right? Feynman, thank you very, very much. Perfect presentation, excellent explanations. And we got a lot of interesting conversations going on right now. So anyway, I think we can continue the conversation there. Thank you.
Okay, thank you. Bye-bye.
Perfect. Bye-bye. See you in a bit. Okay, next up, we have